All right, guys, we are going to do Unit 4, Lesson 1 today, which is going to talk about radical and rational functions. So we're going to be looking at what we call that radical, which is that square root symbol. We can look at it in how we can take the cube root, the fourth root, and so on of different numbers and how we can rewrite them. We're also going to look at what we call rational functions, which is going to have x in terms of a fraction. So we'll see that today. So what we're going to start with first is converting rational or fractional exponents using a radical, using that square root symbol. So what we do here, if we have x taken to a fraction, so this is the exponent, what we can do is that the numerator, the top number, becomes an exponent inside. And then the number, what I like to call on the shelf, is going to be that denominator, right? And so when you take a look here, when you're looking at that line there, that's also called a radicand. Okay, just so that you guys can see the vocabulary. But it's just a radicand, meaning it's like a radical. Okay, so when we go to do these problems with these examples here, we're first going to start with 9 to the 1/2 power. So first I'm going to go ahead and write my base. I'm going to go ahead and write my radical. And then the number inside that the exponent inside that goes in would be 1. And the number on the shelf would be 2. And you guys could actually simplify this to make it square root of 9, which we know is plus or minus 3. And that's it. That's all you do. Okay. If you want to leave the exponent of 1, that is fine. If you want to leave the 2 on the shelf, that's fine. But when there's 9, it just assumes it has an exponent of 1. And when there's a radical, we're going to assume that it is a square root. All right, looking at problem 2. On problem 2, we have 64 to the 1/3 power. So we're going to have, again, I'm going to have my square root symbol. I'm going to have 64. On the inside, because it's the numerator, I'm going to put 1. The number on the shelf is going to be 3. So then what I'm going to do is then I'm just going to simplify. I'm going to have the cube root of 64, and I believe that's 8. But that's all we're doing here. All right, moving on to the next one. This time, if there's a variable in as the base, we can't solve for it, but we can still simplify it. I'm going to write x. Going to write a radical. The number inside is going to be the numerator, which is 2, and then 3 goes on the shelf. And that's it. That's all you do. Now, when it comes to negative exponents, those are going to first go to the bottom of a fraction, and then you can figure out how to write it on the shelf. So when you guys look here, we're going to have, it's really 1 over 16 to the 1/2 power. And then it would be 1 divided by the square root of 16 with the exponent on as the exponent, or 1 as the exponent, and 2 on the shelf. We know that the square root of 16 is 4, so this really becomes 1 over 4. Now, when you're looking at problem number 5, it's a little bit different, but still the same idea. And so what we're going to do is we are going to have, all right, now it should be noted when you look at this one, guys, is that 3 or that 1/7 is only on the x, it's not on the 4. So that stays the same. Then I'm going to write my radical just with the x. I'm going to have x to the first power because that's my numerator. The number on the shelf would be 7. So if I were to simplify this, it would be 4, and we pronounce it root 7. So hold on, let me say that one more time. We're going to have 4, 7 root of x, and that's it. Now this time you guys should see parentheses. Parentheses changes things. That means that 3/4 is going to be applied to the 3 and the x. So what you're going to do is, again, I'm going to do 3x. This time I'm going to put parentheses so I know. And my numerator is 3, so that's going to go inside. And then my number on the shelf is going to be 4. If you wanted to simplify that, you could. We could do the 4th root of 3 to the 3rd would be 27. And then x to the 3rd. and you're done. All right, pretty straightforward. It's not terrible. All right. So what we're going to do is we're just going to quickly go through these problems. Okay. And I'll just do a couple of them and then the rest you can try on your own. All right. Let's see. Let me pick I'll pick the odds and then you guys can do the evens on your own. So again, what you can start doing is making a pattern. If you guys see a exponent of 1/2, we can automatically just assume that it is the square root of 2. And then when we have a negative number, we're also going to assume that it is a fraction already. So I'm going to do 1/9 to the 1/2. I'm going to rewrite it as 1/the square root of 9. And we know square root of 9 is plus or minus 3. So it'd be plus or minus 1/3 as your final answer. On 5. Again, I'm going to have my 7 as my base. My number inside of my number in the numerator is 1. And then my number on the shelf is going to be 3. And I make my radical symbol and put 3 on the shelf. Then there's no way to simplify this. There's no cube root of 7, so I'm just going to leave it like that. And then again, if I see a negative exponent, I'm going to automatically think to put it in a fraction. So then I would have 1/15 to the 1/4 power. And then again, I'm going to have 1 over my radical, 15. Inside the radical is 1. On the shelf is 4. And again, if I wanted to simplify it, it would look like this. And moving on to 9. Again, if I see that negative exponent, I am going to make it a fraction. 1/y to the 1/2 equals 1/the square root of y, because again, I can automatically see that when I have an exponent of 1/2, it's just the square root. Okay, all right, looking at number 11. Again, that negative 1/2 is only on the x, so I'm going to leave the 3 the same. And what I like to do with these is I like to split them up. So I'm going to do 3 times 1/x to the 1/2 equals, and then I can go and multiply 3 over the square root of x. And you're done. You don't have to do anything else. Whereas this time, when you're looking at number 13, that is going to be everything underneath in the denominator. And then it'd be 6x to the positive 1/2 power. And then I just take the square root of that. And you're done. Same idea when it comes to 15. And then again, I'm going to have 1/5. Oh, I don't need a fraction. I just got ahead of myself there. This time, I just need to put it into a radical. My number on the shelf is 6. And because that exponent's 1, I can just leave it as 5x. Good. Now that we've looked at how we can go from rational to radical form, now we're going to go to radicals going to rational form in the exponent. So essentially we're just doing the opposite way, right? And so this time we're going to be given a radical and we have to go to the fractional exponent. Remember, the number inside, that's going to be the exponent inside is going to be your numerator. Your denominator is going to be the number on the shelf. So these ones can get a little bit tricky because sometimes if you don't see an exponent, we're going to assume that it's 1. So looking at number 1, right? What we're going to do is I see that there's a 1 here, and if there's no number, we can assume it's a 2. So this would become 5 to the 1/2 power. And that's it. On 2, my exponent is 2 and the number on the shelf is 3. So this would be 7 and 2 to the 2/3 power. When you guys are looking at 3, remember, if you don't see an exponent on the inside, you're not going to assume it's 0, you're going to assume it's 1. So it'd be x to the 1/4 power. Now, if you guys see a fraction, we need to bring that up to the top. And so what you can do here first is we can do 1 over, and then it should be x to the 2/3 because my exponent is 2 and my number on the shelf is 3. We're going to bring that up from the bottom of the fraction just by making it negative. And it should be negative 2/3. Here, my number that's being rooted is just x. So what we're going to do is we're going to leave the 5 the same. I'm going to have x, and then I'm going to take it to the 1/3 power. Because the number on the shelf is going to be 3, that's my denominator, and my numerator is going to be the exponent on the inside, which is 1. And now this time, though, the 3 is being rooted, so we got to be careful how we do this. So the best way I would know to do it is to use parentheses. So we're going to have 5x squared in parentheses, and then we're going to take it. Now, if I were to put brackets like this around it, it would be to the 1/5 power. And so if we wanted to simplify that, remember this would be multiplied here. This would get multiplied here. So it'd be 5 to the 1/5 power times x to the 2/5 power. All I did was multiply the rational exponent to each number inside the parentheses. If you left it like this should be okay. However, if you wanted to simplify it more, you could. So this time I'll do the evens and then you guys can try the odds on your own. And so again, when you're looking at number 16, the number inside is 1, the number on the shelf can be 2. And I would have 7 to the 1/2 power. Same idea when it comes to number 18. We're going to have 1 on the inside as the exponent and 4 on the shelf. So it'd be 8 to the 1/4 power. On 20, again, my exponent on the inside is my numerator, 2, and my number on the shelf is 3, so it'd be x to the 2/3. And on number 22, I see that it's a fraction, so I'm going to make my rational exponent first, and then I'm going to make it negative. So then I'm going to have 1 over 5 to the 1/3. And then again, I just make it negative, 5 to the negative 1/3 power. I'll rewrite that just to make sure you guys see that it's negative. And then on number 24, again, this whole thing is being rooted. There's a couple different ways that you can do it. I'm going to go ahead and apply that 7 to the 3 and to the x. So we'll have the square root of 3 to the 7th, x to the 7th. And then I can apply the rational exponent rule. And then remember, this is assumed to be 2. So this is going to be 3 to the 7/2, and then x to the 4 over 2, which we could simplify to be a whole number, which would be 3 to the 7th, or 3 to the 7th divided by 2, 3 or 7/2, and then x to the 2nd power, because 4 divided by 2 is 2. And that's all you do, guys. It's pretty straightforward. So you guys try the other remaining problems on your own. You'll have a key, and then work on that homework. Get it done today. If you have questions, go see your teacher. Otherwise, have a fabulous day.